You've probably seen the images, right? The massive offshore rig on fire, the catastrophic oil spill that went on for months. But the headlines, they only told part of the story. The real story, the one we're going to get into, is what happened in the hours and weeks before the explosion. This isn't a story about one mistake. It's a story about how a whole series of things, big and small, went wrong. It's a perfect storm, where every single line of defense, every safety net, completely failed. So let's peel back those layers. And this really sets the stage. Think about that for a second. Long before anything went wrong, the actual crew working on this well had a nickname for it: the well from hell. This wasn't just another job. They knew. They knew the geology was tough, the pressures were insane, and every day was a new challenge. That nickname, it's a pretty chilling sign of the tension and the danger that was already in the air. And this just puts the scale of the whole operation into perspective. On one side, you see the rig, this massive floating industrial city, and the human tragedy of the fire. But on the other side, you see what they were up against: a well plunging more than 3 miles deep into the earth, through rock and salt, pushing the absolute limits of engineering in one of the most hostile environments imaginable. Okay, so let's go there. Let's go back to April 20th, 2010. For the crew on the Deepwater Horizon, it felt like they were on the home stretch. They were just about to wrap up and temporarily seal the well. And then, at 9:49 p.m., it happened. A terrifying geyser of seawater, drilling mud, and highly explosive methane gas erupted onto the rig floor. It was followed by 2 huge explosions that just tore through the platform, engulfing it in flames. The human cost was immediate and devastating. 11 people lost their lives, and another 17 were badly hurt. For 2 days, the rig burned, and then it sank, leaving the well totally open and gushing oil straight into the Gulf. So you have to ask yourself, how on earth does a disaster this huge even happen? Well, it's almost never just one single thing. There's a concept that explains it really well called the Swiss cheese model. Imagine every safety measure is a slice of Swiss cheese. Normally, the holes don't line up, but a catastrophe happens when, by some terrible chance, all the holes in every single slice align perfectly. And that's exactly what we see here, starting with the very first domino to fall. The whole disaster started here, miles beneath the ocean floor, with a piece of hardware called the shoe track. The easiest way to think about it is like the cork in a bottle. It's a cement plug way down at the bottom of the well, and it has one job and one job only: keep all that high-pressure oil and gas safely locked away. But here's the problem. That cork was flawed from the very beginning. BP's own investigation later found a whole list of issues. The cement mix they used was unstable to begin with. Then they used an additive that might have made it even worse. They left out other crucial ingredients. And maybe worst of all, the lab tests they didn't even come close to simulating the real conditions down in the well. So the very first line of defense was basically broken before they even started. So once that cement barrier was breached, a pathway was created. High-pressure gas started forcing its way up, not through the main pipe, but through the tiny gap between the pipe and the rock around it. It was completely bypassing the seal, and nobody on the rig knew what was happening. An invisible time bomb was now racing to the surface. Okay, so the first slice of cheese has a hole in it. A big one. But a technical failure alone shouldn't cause a catastrophe. That's where the next line of defense comes in: the crew. The people on the rig who had all the instruments and data to see what was happening. The failure here, it was all about interpretation. This part is just wild. For about 40 minutes before the explosion, the rig's computers were practically screaming that something was terribly wrong. But look at how the crew explained it away. The pressure was going up when it should have been stable. They dismissed it as a known, harmless glitch. There was unexpected flow coming out of the well. They missed it because they were busy with other tasks, like cleaning mud pits and, get this, giving a tour to visiting VIPs. All the data was right there, but it got lost in the noise and explained away. And this really gets to a deeper problem on the rig. What good is having a dozen different experts on hand if there isn't a good way for them to share information? It's like having a team of brilliant surgeons who are all looking at the same patient, but never actually talk to each other. On the Deepwater Horizon, that breakdown in communication meant that a critical diagnosis was completely missed. So this wasn't just about one crew having a bad day. You have to zoom out. The next hole in our Swiss cheese is much, much bigger. It's about the entire system, the entire corporate culture that set the stage for these mistakes to happen. Yeah, socio-technical system sounds like a mouthful, but the idea is actually super simple. You just can't separate the technology from the people and the organizations that use it. They're all one big intertwined system. A problem with communication procedures can be just as deadly as a crack in a piece of steel. And this is where it got really tangled. You didn't have one company running the show. You had three main players: BP, who was in charge, Transocean, who owned and operated the rig, and Halliburton, who did the faulty cement job. But the lines of responsibility between them were blurry. It created these dangerous gaps where no single person or company had a clear view of all the risks. And this piece of equipment right here, the mud gas separator, is a perfect, tragic example of that systemic failure. When that massive blast of gas finally hit the rig, it was diverted into this thing. But here's the crazy part. The MGS was only designed to handle small, routine amounts of gas. It was never built for a full-scale blowout. It was instantly overwhelmed and ended up just venting a giant cloud of explosive gas directly onto the deck, right next to the rig's huge diesel engines. The system just wasn't built to handle the worst-case scenario. So, you've got technical failures, human failures, and organizational failures. That brings us to the very last lines of defense: the emergency break glass in case of fire equipment and the government agency that was supposed to be watching over everything. This monster is the blowout preventer, or BOP. It's a 300-ton stack of sheer power sitting on the seabed. It is the absolute ultimate failsafe. Its most important job is to use giant blades to just slice clean through the main drill pipe and seal the well dead. On the left is how it's supposed to work. On the right is the reality of what happened. You're not going to believe why this failsafe failed. It had two separate, redundant emergency systems, but in one of them, a key valve had failed, and in the other one, the battery was dead. You can't make this up. It was a complete and total system failure, and even if it had triggered properly, the force of the blowout had already bent the pipe so badly that the blades couldn't have cut through it anyway. And what about the watchdog, who was supposed to be making sure all of this was being done safely? That was the Minerals Management Service. But here's the problem. The MMS had a massive conflict of interest. Their job was to enforce safety rules, sure, but they were also in charge of promoting oil exploration and collecting royalties from it. It's like having the referee also be the team's owner. The official investigation called it a culture of complacency, where the industry was basically allowed to police itself. Okay, so let's put it all together. This wasn't one accident. It was a chain reaction. It was a cascade of failures where every single safety barrier, one after another, was breached. Remember our stack of Swiss cheese? Here's exactly how the holes lined up. First, the technical slice. The cement barrier failed. Second, the human slice. The crew misinterpreted all the signs. Third, the organizational slice. The different companies weren't on the same page and risk was hidden. And finally, the last slice. Both the fail-safe equipment and the government regulator failed. The holes in every single slice lined up perfectly. The story of the Deepwater Horizon is such a powerful lesson because we build and rely on these kinds of incredibly complex systems every day, from our power grids to the global financial markets. And the big takeaway here is that just trying to prevent one single failure at a time isn't good enough. We have to design systems to be resilient, to account for the messy, complicated ways that people and technology interact. And that leaves us with a huge question. How do we do that? How do we plan not just to avoid failure, but to ensure success, even when things start to go wrong? That's a challenge that goes way beyond just one oil rig.